Hello friends, welcome to C# Intermediate to Advanced tutorial. Now we are at final part of the subseries thread communication using AutoResetEvent. In this video, we will implement this example using the AutoResetEvent class. We will also explore how signaled and non-signaled state works. So as usual, we include the namespace, threading and collections. So here we are going to use a stack. That's why we are including the namespace for collection. Next, as a member variable, we create a stack. We have a string, then we have AutoResetEvent. So using this AutoResetEvent, we will protect the stack, which will be shared by the stitcher as well as the former threads. So our form contains only one button, and the button click event will set the string str stitched to empty. It was already initialized, so anyhow we are initialized it again. Then we are creating the AutoResetEvent. Here if you see, we are creating AutoResetEvent. We are passing the false. That means initially it will be set with a non-signaled state. Next, we take our stack numbers and making call to clear. So there will not be anything on this stock initially, but anyhow we are clearing the stack so that the stack will be empty. After that, here if you see, we are creating two delegate, thread start delegate. One is for SUQ form task and another one is for sequence stitch task. So we will create this function soon. So the SUQ form task, this will be done by only one thread. We can call this as a former thread. Next, we will be using 3 thread for stitching task. So we call this as former, the second delegate as a stitcher. Then here if you see stitcher based thread, we are creating 3 threads. Then for former we are making only one thread, and we call that as a T4. T1, T2, T3 are for stitching task. Next, if you see T1, T2, T3, first we are starting the stitching tasks. Then we are giving a 20-second delay. I mean, it's not a 20-second, 20 millisecond delay. After that, we are starting the thread T4, that means former. So in the previous video, we talked about a stitcher. Stitcher will read the stack. It will make a call to pop. Former will push the element, and stitcher will go and make a call on wait one, and the former will make use of set method, thereby signaling the AutoResetEvent. Here if you see, when we are creating the AutoResetEvent, we are creating it in non-signaled state. So that's why first we are asking all 3 threads to go and wait on the wait one. Why? Because it is in non-signaled state. So all T1, T2, T3, or we can call stitchers will be in a blocking state initially. Then T4 comes into picture, I mean the farmer, that will push an element to the stack, then it will make a call to set. So on auto reset event, we will make a set. Okay, anyhow, we are going to do all this in this slide, and that time you will see it. Alright, after starting all threads, so this one is the main thread, right? Main thread is executing all this stuff. This is a UI event, right? So we can call it as main thread or UI thread, and UI thread waits for all these 4 threads. So first it starts all the thread, then it waits for stitcher as well as farmer to finish their task, and main thread waits for it, and once all these thread finishes, main thread quits. Anyhow, here it's a Windows based program. We no need to wait also, but here we are waiting for all the 4 tasks to complete. So this is the sequence farm task, and we know that only one thread will execute this. Thread T4 will run this sequence farm task, and if you see here, we are taking a static number. We want to run this loop 50 times. That means we will push 50 elements to the stack. So here we are just putting a message stating farmer pushed an element, then stack number dot push I. So here we are pushing an element. I means the loop counter, and we are pushing it to the stack. Then we are setting the event. Here, if you see, when we constructed the auto reset event, initially it was kept in non-signaled state. Now what happens, this set event will make our event object to signaled state, then transition it to non-signaled state. So when it moves from non-signaled to signaled state, there will be already 3 threads waiting on for the signal. So one thread will get a chance of releasing from the wait one, and the other 2 threads, before it get released, the state of this event object, auto reset event object, goes to non-signaled state. Anyhow, here we are making the set, thereby releasing one stitcher to perform its task. So here eventually this thread is stating that I'm done with the data. You can make use of data. So here it pushed a data, right? So it's kind of former thread stating that data is ready, and it is signaling by setting the event to the stitcher thread, take the data and print it. So that's what here going on. And if you see, it happens 50 times. So each time it will push an element, and it signals the waiting thread to take the data and use it. All right, so once we come out of this for loop, if you this for loop, right, once we come out of this for loop, we are setting the event 2 more time. Even we can keep 1 more time, thereby releasing any waiting thread. So it will be safe to call set 3 times, so that definitely all 3 threads will get released. Also we have decent sleep time here. Finally, here we are printing farmer quits. Next here, if you see, we are using the sequence stitch task. Here we are taking the thread ID using the current thread property, and manage the thread ID. Then we are printing the thread ID. Why? Because there are 3 threads here, right? In the previous slide, we started these 3 threads during the button click event. So possibly there will be 3 threads which is executing this stitching task. So since there are 3 threads, we are getting the thread ID to know which thread is doing the stitching. Here we are making use of the while loop, and we are printing stitcher thread ID waiting. Why? Because here we are making call to event.wait1. So this will be the blocking call. Whenever the sequence former sets the event, the thread, whether it is T1, T2, T3, and if you see there are T thread, right, all will wait here. T1, T2, T3 all will wait here. When the former sets the event EVT, if you see all threads are sharing the same auto reset event, here it is signaling, and the waiting thread will get released based on the signal. So once it is released, it will, any thread T1 or T2 or T3, it will move ahead and checks the stack numbers. This is the shared resource, right? And checks the count. If it is 0, we will come out of the loop. We will come out of a while loop. So this is the while loop, right? We will state stitcher quits. All right. So when there is at least one entry, then we will not break out of the while loop. We will come here and we will append stack numbers.pop, whatever it pushed. Let's state it pushed element 4. Here that element 4 will be popped out, and if there are previously 3 elements, we will be having 1, 2, 3 and 4. Then we will append a comma with whatever is pushed previously. So we will be seeing output like 1, 2, 3. Now 4 is pushed, right? 4 and a comma. Then in the console, we just write this str stitched. We also write stitcher which thread stitched this last popped up element. So here we are popping the element, right, and we are appending it to the str stitched. So here we state stitcher thread number, say for example T2 stitched, then the stitched string we are displaying it. Finally, we give a 10 millisecond sleep, so it will go ahead and wait on the auto reset event object. Here if you see, the wait is 100 millisecond. Here it is just 10 millisecond. That means we will make all 3 thread wait on the signal. So all 3 thread most probably will go and wait for the signal, and once it gets the signal, any thread will enter. All right, that's all here. And if you see the role, the sequence former task T4 will signal, and since our object is auto reset event, it will automatically go to non-signaled state. During this signal time, the waiting thread, if you see T1, T2 and T3, will get released on this wait 1, and then go ahead and read the content pushed by the former thread. Here we are popping. That's all here. Now we will go ahead and implement this code change. Here our form is ready. And if you see, our form contains only one button, and we will handle the click event of this button. So first we will keep the namespace ready to work with AutoResetEvent. Next, as a member variable, we will declare stack string as well as AutoResetEvent EVT. So in the click event, if you see, we are initializing our string AutoResetEvent. We are keeping it in non-signaled state. And if you look at the Boolean value indicating whether to set the initial state to signaled. So we set false, that means it will be not in the signaled state. Then we create our former and stitcher threads. Then main thread waits for all these 4 threads, and we are asking the stitcher to go and wait on the wait one call, and after 20 milliseconds we start our former. So they all wait for the signal. So after 20 millisecond delay, the thread T4 goes in and it puts the very first element, sets the event. So any one thread here will get released from wait 1. So here we keep the sequence form task. So this is the delegate, right? Delegate, which points to the function, and here is the sequence form task, and we are pushing the element to our stack. And here, as already told, we are setting the event 3 times so that we double check to signal all 3 threads towards the end. And now we have the stitching task, and this will be executed by 3 threads as already shown in the slide. This stitching task will be executed by 3 threads. So now we will build this once. Let me clear the output window. All right, main thread is not waiting. That means it is not blocking here. That's why we can able to move the window. I mean the UI is responding. Now let's look at the output, and if you see here, I'm not sure what happened to the initial stage. Let me run this again. All right. So if you see, stitcher 10 is waiting, 11 is waiting, and 12 also waiting, because we started thread T1, T2 and T3 first. T1, T2, T3, T1, T2, T3 are stitcher. So there are 3 stitches. They are waiting on the wait 1. So after 20-second delay, farmer started and it pushed element 1. After pushing the element, it will make a call to set. So any stitcher will get released from the wait 1 call. Here if you see, stitcher 10 released from the wait 1 call and it stitched the element 1. So this is push and this one is a pop. So whatever is pushed by the farmer thread, that will get popped by the stitcher. So likewise, if you see, farmer pushed element 2 and it sets the event. This time thread 11 released from the wait 1 call and it picked up the element 2 and stitched it. So likewise, if you see, we will be seeing the thread picked up the final element 50 and it stitched that. So here if you see, the thread is 11. So stitcher thread 11 picked the element 50 and it stitched it. Then stitcher 11 gone into waiting stage. Here stitcher 12 quits, then 10 quits, then farmer also quits, then stitcher 11 also quits. So all 3 thread quits plus farmer also quits. So here you will be seeing exit code for the threads. So that's all here. So here in this case, if you see, this one will set the event farmer and stitcher will wait for the event signal. Once it received the signal, it picks up the element. So this is kind of stating data is ready. I pushed element 4. Then anyone waiting stitcher will wake up and it will pick up the pushed element and perform the stitching. So that's all here in this video. Just now you saw the demo. Thank you for watching. Bye.